So hello Year 12, and I thought it'd be quite useful for me to go through the mark scheme for those Group 2 questions that I set you last week. It was quite apparent that quite a lot of people had not watched the video that I set, which is fine if you had done the revision separately in your own way. However, there's an awful lot of people who genuinely don't know the important concepts from Group 2, and given it was only 4 lessons long, there's not really much excuse for you to not know how to do a flame test, how to explain polarization of the anion. So we'll go through the questions, I'll highlight important points from the mark scheme, and hopefully you'll find this useful. So question 1, the presence of some ions in compounds can be identified using a Bunsen burner flame. Some metal ions give characteristic colours in a flame test. Describe how to carry out a flame test on an unknown solid. 2 marks. Okay, first mark was for specifically talking about a nichrome or platinum wire, or if you wanted a ceramic or silica rod. That was mentioned several times. Lots of people just talked about a wire. Lots of people talked about an inoculation loop, which is absolutely rejected by that. The other thing, you had to talk about using concentrated hydrochloric acid or dilute hydrochloric acid at some point to clean the wire, and dip into the sample and place over a blue Bunsen burner flame for the second mark. So if you didn't talk about HCl and you didn't talk about nichrome or platinum, you were getting 0 out of 2. Which of the following ions does not give a red flame? Well, hopefully you recognise barium. Barium actually here gives a green flame. So A does not give a red flame, barium gives a green flame. Some anions can also be identified by heating in a Bunsen burner flame. A compound is heated in a test tube in a Bunsen burner and it gave off a brown gas and caused a glowing splint to be relight. The formula of the ion responsible. Well, the thing that decomposes to give oxygen and nitrogen dioxide is the nitrate anion, C. Okay, so the nitrate anion is the thing that decomposes, gives off nitrogen dioxide and oxygen. Lots of people going for NO2 minus. No, NO2 is the gas, NO2, but NO2 minus is nitrite or nitrate 3. That's not the ion that decomposes. A flame test on a white powder gave a lilac flame. From GCSE you should know that's potassium. Dilute hydrochloric acid was added. The gas produced bubbled in lime water. That's clearly carbonate. This is GCSE. No excuse for not getting this right. Give a possible formula. The number of people that wrote the name of this thing. So K2CO3 or even K8CO3 was what they wanted. For 1 mark, allow potassium carbonate. But there was 1 mark for getting K+, 1 mark for getting CO3 2-. Okay, but potassium carbonate was what it wanted. But pay attention, it's in bold formula. The labels on 4 colourless solutions had fallen off in storage. It was known that these solutions were this, which would produce a lilac flame. You know from GCSE that's something with potassium. So that would be C, potassium chloride there. Which of the following diagrams best illustrates the electronic transitions that take place during a flame test? Well, heat is used to excite something from the ground state, an electron from the ground state to an excited state. As it drops back down to the ground state, when it's cooling down, energy is released as a photon of light, so it is B. Energy is certainly not released going up to the excited state, so you could rule out A, C and D just because none of them release energy going up to the excited state. Which solution produces a white precipitate with acidified barium chloride solution? This is again GCSE. Barium chloride identifies sulfate ions, and so therefore B, magnesium sulfate, is the answer to that question. 2 of the solutions produce the same result on the addition of dilute nitric acid followed by silver nitrate solution. State the observation, again from GCSE. Nitric acid and silver nitrate are used to identify halide ions. So chloride would give a white precipitate, bromide would give a yellow precipitate, bromide would give a cream precipitate, iodide would give a yellow precipitate. Here you have two chlorides, so they would give a white precipitate for 1 mark, and the two are hydrochloric acid and potassium chloride. Can be in either order. Allow A and C. If hydrochloric acid and sodium carbonate react together, the observation you would make is you would see fizzing, bubbling, effervescence. Ignore CO2. You don't know carbon dioxide is being given off. You can just see bubbling. One person did say bubbling that would turn lime water cloudy. Yeah, okay, you would see that. The ionic equation, many people got this, but lots of people forgetting the charges. 2 protons from the acid, the carbonate anion forms CO2 and H2O, 1 mark there. Now this was quite a difficult question. Some people really misunderstood what was needed for this question. A 6 marker. A student suggested that the difference in the rates of reaction of strontium and barium with water is due to the differences in the sum of the first and second ionization energies. Discuss this suggestion. Right. First things first, I want to highlight here. If you want to get full marks, you have to say all 6 of the following things. So, number 1. The first 2 ionization energies summed up is lower for barium than it is for strontium, or barium loses its outer electrons more easily. That's the first marking point. Secondly, you have to say that barium is bigger, or barium has a larger atomic radium, or barium has more shells. The third thing, you have to at some point talk about barium having more shielding. But you've also got to note that barium has a greater nuclear charge, but this is outweighed, it's a balance, but it's outweighed by this more shielding and larger thing. So therefore, number 6, barium reacts faster, or barium is more reactive. Now, if you got all 6 of those points, you get 4 marks. 5 or 4 of those points, 3 marks. 3 or 2 of those points, 2 marks. 1 is 1, 0 is 0, okay? So that is for those points that we just looked at. On top of this, if you have a well-structured, easy to follow argument, you get an extra 2 points for the grammar. If your argument's a little bit all over the place, you get 1 mark. And if it's a mess, you get no marks. So the sum is up to 4 for the content and up to 2 for the structure of the argument. Many people did not discuss the effect of nuclear charge at all, and the fact that was outweighed by the shielding, so they were pegged at 4 or 5 marks. But that's how that was marked. Which is the equation for the third ionization energy of barium? Well, this would be removing the 3rd mole of electrons from a mole of gaseous barium ions. So clearly not this, because that's a solid to start with. Clearly not this, because that's a solid to start with. That is removing the 4th mole of electrons, so that is the 4th ionization energy. So it is C, barium 2 plus gaseous ions, having an extra electron or mole of electron pulled off a mole of gaseous ions. Right, this is the one that told me some of you haven't bothered to revise this at all. Explain why magnesium nitrate decomposes more readily on heating than potassium nitrate. I went through this in the video. We spent time in the lessons going through this. There was no excuse for people to get 0 out of 4. You need to talk about the fact that magnesium is smaller and has a higher charge, so it has a higher charge density, okay? So higher charge density for the first 2 marks. Therefore, it polarizes the nitrate more. I had people talking about magnesium nitrate being polarized, or electrostatic forces, or covalent bonds. Okay, no, it's distorting the electron cloud. It's distorting the nitrate ion for the third mark. And finally, this means it weakens the NO bonds more, or weakens the nitrate bonds more. Very few people getting 4 out of 4 there, despite the fact that this is something to just learn so you can regurgitate. Draw a diagram of the apparatus that could be used. Compare the ease of thermal decomposition of lithium carbonate and magnesium carbonate. Again, this was in the video. I highlighted how regularly this is asked. Some people had obviously never encountered this practical. So you just need some diagram showing suitable apparatus in which a sample of carbonate can be heated, 1 mark, and either a delivery tube going into the lime water or gas collected in a gas syringe for the 2nd mark. Not collecting it in a test tube. Loads of people not putting the delivery tube into the lime water. You don't get that. Don't award if the lime water is in a sealed apparatus. Don't award if it's heated in a water bask. Don't award if it's heated in a conical flask or a crucible or an open tube. It's really easy to get these 2 marks, but lots of people didn't. How could we have a fair test? Same Bunsen setting or same distance between the flame and the test tube. Don't award same mass of metal carbonate. Ignore reference to same apparatus. Allow same depth or volume of lime water. Some people went for that. Oh, it says allow same amount of metal carbonate. I didn't, because that word amount is vague. So I didn't allow that, although it does say you can on the mark scheme. Ignore same amount of heat or same temperature, because that's virtually impossible in one of these experiments. You can't check that the crucibles, you can't check that the Pyrex tube is at the same temperature. How would you make a comparison? Well, time taken for the lime water to go cloudy, or time for a given volume of gas to be produced if you're using a syringe or measuring cylinder over water. Now, lots of people said, oh, final volume of carbon dioxide, but one of your controls should be you have the same number of moles of each carbonate, so therefore you should produce the same volume of carbon dioxide at the end anyway. Fireworks are designed to explode in a controlled manner with bursts of brightly coloured light. Give the formulae of 2 metal carbonates that could be used to produce a bright red colour from an exploding firework. They wanted you to talk about strontium and lithium. Penalise use of names rather than formally once only. Reject calcium, and that's because calcium is red-orange. So it's not a bright red colour. The other one that surprised me, they didn't allow rubidium. And reading around the subject, that's because rubidium gives a deep red colour. A much deeper red, almost purpley compared to strontium and lithium. And therefore they're probably arguing that that is not a bright red colour. But I thought that was a bit harsh. Explain by reference to the electronic transitions how the metal ions produce the colours in the firework. Very simple, but some of you cannot explain this. You've got to be able to explain it. Heat, and lots of people miss this, heat promotes electrons to a higher energy level, 1 mark. These electrons return to the ground state, almost everybody got that mark. Energy is released in the visible part of the spectrum. Now, I'm not sure. Lots of you said, oh, releases coloured light or releases different colours. I'm not sure that satisfies that same marking point. So to play it safe, I have not marked that, and I've said include visible. So if you ever get one of these questions, they do come up fairly regularly. Mention releasing visible light, because if they don't release visible light, you will not see colours in the firework. Suggest a metal which may be used to produce a white colour in a firework and give the name of the compound produced. Almost everybody went for magnesium, producing magnesium oxide. Some people were lazy, only wrote magnesium oxide. and therefore only got 1 mark out of 2. You could have also have had aluminium or titanium, although I'm not sure you would have encountered that idea. It does suggest that one of the products formed could have been magnesium nitride because of the very high temperatures. No one went for that, so I'm not going to dwell on that. Almost everyone got this. 2 KNO3 plus 1 sulfur plus 3 carbons, 1 potassium sulfide, 1 nitrogen and 3 CO2. 1 for CO2, 1 for correct balancing. It says allow multiples, I've just noticed, so one of you is owed a mark because you did 4, 2, 6, 2, 2, 6, but that was only one person. Identify the 2 atoms that have been reduced to state the change in their oxidation numbers. Nitrogen's been reduced and sulfur's been reduced for 1 mark. You had to get both of those for the first mark. Nitrogen goes from +5 to 0. Sulfur goes from 0 to -2. That is for the second and third marks. Lots of people getting full marks here. About half of you getting full marks for this. Lots of people being silly. In particular, just missing the lone pairs off the oxygen. That's just careless and losing marks unnecessarily. But you can see that one method is you've got a double bond between each of these oxygens and each of these chlorine, a single bond here, and the extra electron. The number of you who did not read the bit where it says use an asterisk for the extra electron, number of people just missing marks because they're not reading questions carefully. Correct dots and crosses on 3 oxygens for the double bonds to the chlorine. Allowed dots, crosses and asterisks on the 4 oxygen. Allowed the asterisk electron to be anywhere on the 4th oxygen. A lot of people, 3 dative bonds from the chlorine. This is absolutely fine. So we've got 3 dative bonds here and then a final single bond to that oxygen. All of that was acceptable. Lots of people getting full marks, lots of people getting 0 because they made 2 careless mistakes. Describe how the fuse in the firework starts the chemical reaction and why it is not a catalyst. The fuse releases energy or reacts exothermically. This provides the activation energy. But it's for the third mark, why is it not a catalyst? It's used up in the reaction, or it does not lower the activation energy, or it does not provide an alternative reaction pathway. This is GCSE. Some of you describe that terribly, okay? Some of you getting 0 marks there. GCSE energy changes. And finally, use your knowledge of reaction kinetics to suggest 2 factors that could affect the rate of reaction of the solids in a firework. Reference to any 2 suitable factors from surface area, temperature and concentration. Lots of people mentioning catalysts, not allowed by the mark scheme, I'm afraid. So 1 mark for mentioning 2 of those. Any 2 from surface area. Increase will increase reaction rate because more particle-particle contact. Temperature, more exothermic, more heat given off will increase reaction rate because particles have more kinetic energy for the reaction or concentration. More tightly packed will increase reaction rate because more particle-particle contact. You just had to use some GCSE collision theory there. But again, many people getting horribly confused here, and I had loads of discussions about promoting electrons. That's something completely separate. That's your flame test. You're promoting the electrons they're dropping down to give out the light. That's nothing to do with the speed of the chemical reaction that's going on. And some of you really were not following this question very well. Okay, so I believe that you've all been sent this email, so you know that your end of year test is coming up. This week is revision week, so I've given you loads of stuff to do. If you have done all of that, then very well done. I suggest what you do is you look for past papers online and you try a paper 1 past paper and a paper 2 past paper. There will be a link to those on Show My Homework. So I'm not going to set any specific work for you this week and I'm not going to take anything in. A word of warning. Your end of year exam is going to be in this format. It is going to be a Google form that will go live on Google Classroom. If you look at the timetable, 3 p.m. on the Monday. That's chemistry. So the exam will go live at that time. It will be available for about an hour and a quarter. That should be enough time for you to complete the paper, upload anything you need, and then the form will close. So you cannot miss that slot, or we will deem that you have not done the end of topic test. If you do have any questions, any problems in the last week, email me at the usual address. And then the last week before half term, on the Monday, exam week, your test will go up. Good luck over the next couple of weeks. I guess I shall be interacting when I mark all of your scripts in about 10 days' time. Goodbye.